All right, so we're going to be looking at linear and quadratic regression. Now let's first talk about the word regression. Regressions are used to find an equation that best represents or best models a set of data. And then from the equation, we make predictions. All right, so we go from data, and from the data, we find the model that best fits the data, and this is where our R squared comes in, and we'll talk about R squared in a bit. Then after that, we're gonna get an equation, and after my equation, we make a prediction. And that's what we use data for, right? We gather data so we can make predictions on what can happen as well, without it actually happening yet. All right, so let's talk about that R squared. But first, we're going to talk about R. Do you guys remember R from not elementary school? Woo! From 9th grade, correlation coefficient? Guys don't remember it? No? Well, your R is your correlation coefficient. And this correlation coefficient tells us how strong the relationship is between X and Y. And if it was positive, it had a positive correlation. If it was negative, then we would have a negative correlation. But for this, we're going to look at R squared. Now, what R squared tells us is how much of a percentage the points, or how, hold on, I need to collect my words. The percentage of points that will fall on the line. So let's say the number is 50%, then that means 50% of those data points will be on that line. If it's 80%, then, or 0.8, which is 80%, then like 80% of those data points will lie on that line. And what if it's at 0.2%, or 2%? Then that means little to no points will lie on that line. So your R squared is the percentage of points on the line from the data. So obviously we want a big percentage, right? Because we want most of the points on that line. And the smaller the percentage, we wouldn't be able to use it too much to predict anything. All right, so I'm gonna put a little number line, oops. And if my R squared is 1, then that means 100% of my points are going to fall on that line. If my R squared is 0, then that means none of them will lie on that line. If it's in the middle, let's say it's 0.5, then that means 50% will lie on that line. So that one, we may or may not use it for predictions. All right, so let's look at some examples of what that might look like. So let's say we have these data points and we use regression to come up with an equation. Once we get regression, it'll give us an R squared. This strength is 0.634, which means that if we multiply this by 100, we're basically moving the decimal place twice, and that gives us 63%. Now with 63%, it's not the greatest type of model, quadratic, but it's pretty moderate. We might be able to use it. So I would call this a moderate quadratic model, not too reliable. But I mean, if we need to use it, we would be able to. Now, if I have another model where all my data points are touching that quadratic model, and I use a regression, then my R squared is probably going to be 1. And 1 is 100%, which means 100% of those data points are going to be on that graph. So this is a strong quadratic model. Question so far? All right, let's move on to linear. Let's say we put these 4 points on our calculator. We did a regression, a linear regression, and then they gave us the equation to this line. And then we look at my r squared, and my r squared is 0.2. Now to find the percentage, move it twice, and we get 20%. So would this be a good linear model, or would it be a very weak one? It would be super weak, right? So this is a weak linear model. Now let's say we put these points on a line and we get an r squared of 0.99. Again, to make it a percentage, we move the decimal over twice. That gives us 99%. Would this be a strong or weak linear model? It'll be a strong one. It's almost close to perfect. Now, if you guys can remember from the beginning where we talked about what a regression was, notice how we said that best fits this model. Can we get an equation that is linear? Yes. Can we get an equation that is quadratic? Yes. But we want to find the one that is best to represent that model or that data so we can make good predictions. All right, so this is where we're going to use our calculator. But before we do that, I'm going to show you the equations. So let's put use calculator or using calculator. Oof, I can't spell this afternoon. Using calculator. To write regression. There's a ton of math involved to do it by hand, so we're letting the calculator do the work for us. We need to learn how to do it with the calculator. So the equation for linear that we'll be using is y equals mx plus b. Slope-intercept form. And for quadratic, when we get the regression, it gives it to us in the standard form, which is ax squared plus bx plus c. I'm going to give you guys the steps first, and then we'll do it together. So step number 1, we're going to go to desmos.com, and we're going to choose a graphing calculator. Step number 2, there's going to be a plus sign on the top left corner that we're going to click. And then we're going to choose table. After we choose our table, we're going to enter our data. And after we enter our data, we're going to first find a linear regression, and then we're going to find a quadratic regression. And then we're going to compare them and see which one best fits. So for our linear, we need to type this exactly the way it is, or else it's not going to work. Trust me, because I tried it. So you're going to put y1, and then you're going to put this little squiggly line. Now on a standard keyboard, it's like on top of the tab key. You have to push shift and then that key on top of the tab. And then we're going to put mx and then again that little subscript 1 plus b. Because what this program is going to do, it's going to get your x value and your y value, and then it's going to plot it. And then we're going to get this information. We're going to get our r1, our r squared. Oopsie. We're going to get our m, because that's going to be our equation, and our b. Then we're going to go and type. So let's put linear for this one. I don't want to confuse you guys when you do your notes. Put it down here. This is for linear. So for quadratic, we're going to type y1 and then that little squiggly, ax squared 1, or I think it's x1 and then squared. I can't remember the order, or I don't even know if it matters. And then bx1 plus c. And on that one, we're going to put r squared, our a, our b, and our c. You okay? All right, so let me give you the table, and then we'll do it together. So this is X hours studying, and Y is going to be the grade. So this data that was gathered compared the hours somebody studied to the grade that they got. So if they studied 2.3 hours, their grade was an 81. 1.7 hours, grade was an 83. 5.6, 93. 3.2, a 95. 2.1, they got a 78. 3.3, they got a 91. 0.5, they got a 60. 1.1, they got an 80. And 1.9, they got these things down. 61, which means it's 61%. And then we're going to write down our M, which is 5. Let's say 6. And then my B, which is 69.7. All right, so what kind of regression would that be? Do you think it's pretty weak, strong, or moderate? It's pretty moderate. So let's find out if, make sure we write down linear next to that one. And now let's do a quadratic regression and see if that relationship is great. So we do y1 squiggly ax1 to the second power plus bx1 plus c. Pull this up, zoom off, zoom on. There we go. There we go. Make sure it matches what I had before, and it doesn't. I did something wrong. Let's try this again. ax1, second power. Why is it capital? All right, try this again. ax1, power of 2, plus bx plus c. Why is there equals? Shift, Miss Silva, shift. All right, here we go. Perfect. All right, so let's go ahead and write that down. So our r squared is 0.83, which is 83%. And then my A value is negative 1.8. My B is 16.78. Or let's round it to the nearest tenth. 16.8, and my C is 56.7. All right, so how strong is that one? It's pretty reliable, right? All right, so let's go ahead and let's look at our notes. Here we go. Almost done, guys. We'll make predictions on Monday. I'm sorry? I'm going to put it on the notes now so you can see what I wrote. Yes, is that what you were looking at? All right, so if you didn't write it down, go ahead and write it down. And it's not necessary to write both equations down because we only need the one that's the best model, right? So because 83% is better than 61%, so we could say that this has a good or a decent correlation, a quadratic correlation. So let's write down the equation. We've got f of x, and it's supposed to be ax squared plus bx plus c. We're going to say y is equal to, and then substitute my a value, x squared, plus my b value, 16.8x, plus my c value of 56.7. It's not, yeah, it is. So my A is here. My B and my C. So on Monday when we predict, we'll use this equation to predict. Any questions? All right.